let's begin with today's session on electrical engineering at So, a little bit about me. As I mentioned, my name is Fatma, and I'm a third year electrical engineering student, and I'm also the electrical engineering student ambassador. I'm from Karachi, Pakistan, and I live in Riyadh, Saudi Arabia. Some of the things I've done at York is that I was a volunteer for York International in my first year, and I was also a social media director for the Lausanne Engineering Society. And currently, I'm the president of her campus at YorkU, which is an online magazine. Over the summer, last summer, I worked as an undergraduate research assistant for one of my professors. And in terms of academics, something I'm really interested in is power systems and electrical machines. So here's a little bit about today's session. Here's everything we have lined up. We will begin with an overview of our program, followed by some of the courses you will be taking and highlights. We will touch on co-op and extra support and resources you have available at work. I also have a session for FAQs and a live Q&A. And if you have any questions, meanwhile, feel free to drop them in the Q&A and I will get to them at the end of the session. Yes. So let's begin. Firstly, we will start with an overview of the electrical engineering program. So here's a little on our first year. So we have a general first year, which means everybody in first year, regardless of your major, will be taking the same courses. So because of through a first year, you can explore different engineering disciplines such as civil, mechanical, electrical, or software before you choose your specialization in second year. This ensures a better fit for your interests, and you will be taking core courses in applied math, sciences, programming, which will provide a necessary foundation for your upper year specialization. Because of a first year, you will also common first year, you will also have time to learn more about different career paths, which also reduces the pressure of choosing a specialization straight out of high school in case you're unsure. And having a common curriculum also encourages strong um, peer relationships, which help aids in collaboration and social adjustment to university life. And most of these programs and courses focus on project-based learning. You will be doing a lot of projects and group work, which teaches you communication, teamwork, and other technical skills. So what are some of the courses that you will be taking in first year? So for math, we have Calculus 1 and Calculus 2. Calculus 1 is differentiation. Calculus 2 focuses more on integration. And we also have linear algebra. You will have two engineering design principles courses. These are not technical courses because those begin in second year. Instead, they focus more on how engineering projects work, and they also have a lot of group work and projects. Then you will have two programming courses. The first one in MATLAB, the second in Java. For your science courses, you have Physics 1, Physics 2, and Chemistry. And if you're taking electrical engineering, your final course in first year will be a math course called Discrete Math. Okay, so now we have some more information on upgrading and customizing your engineering program. So when you first apply, you are admitted to your general Bachelor of Engineering degree. So this gives you a broad foundation across the different disciplines. And after you complete your first year, you will have the option to customize your degree based on your interests and career goals. There are three main ways to do this. So firstly, after your first year, you will be choosing a specific field, such as electrical, mechanical, software, computer, civil, space, or mechatronics engineering. These are the seven engineering programs that we offer. So this allows you to focus your studies and get more, build more expertise in your chosen area. If you are already sure before you even begin your first year about what engineering program you want to pursue, you also have an option to apply for an engineering program guarantee. Your second option is called the International Development Studies dual degree. This is a great option. Oh, sorry about that. Okay. So this is a great option if you are interested in combining engineering with um, a global and sustainability focused perspective. You will learn more about the social, environmental, and economic factors that influence engineering challenges. And through this degree, you will take courses related to topics like culture, migration, and global politics. So the Bachelor of Engineering degree is 4 years, but if you opt for the International Development Studies, it will be a 5 year program, and you will graduate with both a Bachelor of Engineering and a Bachelor of Arts, which can open doors to more interdisciplinary careers. And finally, we have something called a BEST certificate. So this is a multidisciplinary certificate which is designed to develop your entrepreneurial and leadership skills. It will help you gain real world experience in areas like business and innovation, while also helping you expand your professional network. And overall, this BEST certificate is a great addition if you're interested in startups, getting more leadership experience, or combining engineering with business. So after first year, overall, you are not locked into one path, and you have multiple ways to shape your degree based on what you're interested in and what you want and where you want your career to go. There's okay, I see a question. Is first year a course heavy year or is it distributed? So normally in first year we have 11 courses. The recommended schedule is that you take 5 courses in fall and 6 in winter. So I can tell you which courses are these are. Right. Okay, so out of this list, the courses that you will be taking in fall are Calculus 1, Linear Algebra. One of the Engineering Design Principles courses, you will take MATLAB and Physics 1. For winter, you will have Calculus 2, the second Design Principles course, Java, Physics 2, Chemistry, and Discrete Math. But this is a recommended schedule. You can also move courses around. You also have the option of taking some of these courses in summer if you want to have a lighter course load in first year. As long as you meet all the prerequisites, you can shuffle them or take courses in a different sequence as well. Okay, so we're done with this slide. Now, a little more on electrical engineering. So, electrical engineering is a field that focuses primarily on designing and analyzing systems that use electricity and electronics. So, this includes things like circuits, power networks, electronics, and other communication systems. If you are an electrical engineer, you will be working with technologies that power and control most of the systems that we use every day. So think from your smartphones to your computers to renewable energy systems and all the power grids and equipment that supply electricity to our homes. One of the reasons electrical engineering stands out so much from other engineering programs is how versatile it is. The skills you learn can be applied across many different industries, including energy, automation, and communications. So there's a lot of specialization options. Because electricity and electronics are such a big part of modern technology, electrical engineers play a key role in developing new innovations and improving our existing systems. Electrical engineering also is a very, I'd say, future focused and future proof field. As we know, electricity is the backbone of modern technology. And with all the recent advancements that we've been making, there is always an increasing demand for engineers who understand these things, engineers who know how power systems, electronics, and other smart technologies work. Electrical engineers contribute to different areas like renewable energy, electric vehicles, smart homes, and communication networks, which are all important for the future. Another advantage is the variety of career paths that are available. For example, once you graduate, you might work as an electronics engineer, designing devices or control, you might go into controls and instrumentation, or maybe you can be a power distribution engineer, someone who helps design and maintain our electrical grids. Some graduates also go for a completely different route with project management and consulting, where they apply their technical knowledge to lead projects and solve complex engineering problems. So, in short, electrical engineering is very innovative and versatile with great career prospects. Mhm. Okay, so here are some of the highlights of our electrical engineering program. So this slide highlights the core curriculum as well as some of the technical skills that you will gain in the program. So let's start off with the curriculum. These are some of the key courses that form the foundation of electrical engineering. So we will start with electrical circuits, which in my opinion is the most foundational electrical engineering course that you will be taking because all the knowledge that you gain from your other courses, everything will be built upon the foundation, the things you learn from this course. So this course basically teaches you how to analyze and design basic circuit systems. You will be working with voltage, current, and different power relationships. The follow-up course to this is called Electronic Devices and Circuits, where you will learn more about electronic components like diodes and transistors and how they can be used to form real electronic devices. Next, we have Signals and Systems, which is a really difficult course, but also very important because it focuses on how signals like audio, data, or other sensor outputs are represented and processed. So, this is the foundation for areas like communications and control systems, which is what things like radio and Wi Fi work on. You will also take a course called Applied Electromagnetism, which explains how electric and magnetic fields behave and interact. This is especially relevant for things like antennas, wireless communication, and other energy transfers. Finally, we have power systems, which basically looks at how we generate, transmit, and distribute electricity on a large scale. So this is basically how power is generated and then distributed from the plant to our homes. And my personal favorite course is electrical machines, where you learn more about how devices like motors, generators, and transformers work. And it's also a great example of theory being applied to real world systems. And if you look on the right side, here are some of the technical skills you will develop through these courses. Firstly, you will build a strong programming foundation, which is essential for modern engineering work. You will also gain experience in electronic circuit design and testing, which means you won't just be learning theory, you will also actually build and analyze these circuits. Another area is embedded systems and the development and digital logic design, which involves programming hardware like microelectronics, something that you will start working on from your first year with your Arduino type projects in your programming courses. You will also learn circuit design for more advanced applications, including chips, electrical machines, and even antennas. And finally, you will develop skills in signal processing and analysis, which is used in everything from communications to audio to image processing. So, overall, this is a well rounded curriculum which is designed to give you both a strong theoretical knowledge and practical hands on skills that are directly applicable in the industry. Okay, so future ready features. This slide focuses on how our electrical engineering program stays future ready and prepares students for evolving industries. So first, our program offers modern, up-to-date courses in area like renewable energy, electronics, and smart technologies. This is important because engineering is constantly changing. We're having a lot of advancements in these industries, and these fields are becoming more relevant in today's world, especially as we transition towards sustainability and automation. Another key aspect is our emphasis on hands on learning. You won't just be learning theory, you will also learn how to apply it through your labs and design projects. Most of your courses will have either of the two. You will have labs and design projects, which helps bridge the gap between understanding concepts in class and actually using them to solve engineering problems. This program also uses and incorporates a lot of industry relevant software and tools, which means you will gain experience with the same technologies and software real industry professional use in the workplace, which makes your transition to internships and jobs more smoother. In addition, we have frequent networking opportunities such as industry nights, recruitment events, and guest speaker sessions. Attending these events can help you connect with industry professionals, learn more about different career paths, and explore internship or job opportunities. And finally, this program places a strong emphasis on soft skills, which includes problem solving, teamwork, and communication. So these are just as important as technical skills because when you're working in real life, you're almost always working in teams, you're constantly interacting with different people, and you need to have those skills in order to clearly communicate your ideas. So overall, our program is designed not to just teach you engineering concepts, but it also helps prepare you with the practical skills, experience, and connections that you need to succeed in your career. Okay, so let's talk a little more about co-op and some of the extra resources we have available at York Amazon. So this slide covers co-op and what you can expect, which is one of the biggest advantages of our program. Students are eligible for co-op after second year. Once you've built a strong academic foundation, you cannot do co-op after first year, it's only after second year. So before starting, there are three mandatory preparation sessions that you have to attend. These focus on resumes, cover letters, and interview skills. These sessions are really helpful, especially if you don't have prior work experience, and our co-op advisors will also help point out if you need to make any changes or give you more advice. We also provide a lot of ongoing support. So we have co-op advising, resume, and cover letter workshops, as well as mock interviews to help you prepare for applications. In addition, our Career Center also offers extra resources, so you're not going through the process alone. Our team of co-op advisors are always available to help you out, whether you need help searching for a job, filling out your applications, or even if you started co-op and need help with anything, they're always available. In terms of compensation, our average salary is around $28 per hour, but this depends on your year of study as well as the company and what role you're doing. But co-op in general is a great way to gain experience while also earning money. Now, in terms of why co-op is important, there are a few key benefits. So first, you of course gain hands-on paid work experience, which helps you apply what you've learned in class to real engineering problems and also to earn some money. Second, you will build professional skills and industry connections, which can make a huge difference when applying to full-time jobs after graduation. And finally, it allows you to explore different career paths early, so you can figure out what areas of engineering you are actually interested in once you graduate, because this is not something you will probably not have once you have graduated. And if you look on the right side, we have some of our top employers students have worked with. These include uh, utility companies like Ontario Power Generation and Toronto Hydro. We have tech companies like IBM, AMD, Amazon, Google, financial institutions like TD, CIBC, Scotiabank, and some students have also gone to work in construction companies like Modern Niagara and Aecon. So overall, co-op gives you a major advantage because it combines academic learning with real-world experience, which often leads to stronger job opportunities after you graduate. So here are some of the opportunities we have outside of co-op because not every student is successful in securing a co-op term. Not every student wants to do co-op. So I've highlighted some of the opportunities available beyond the classroom, which are also just as important as academics in shaping your overall experience. Starting with research opportunities, some students also have access to several programs and facilities. We have undergraduate research awards called LURA, which is the Lausanne Undergraduate Research Award, and NSERC QSRA, which support undergraduate students in research roles. We are also home to 4 research units and as well as other research facilities and labs. We have another research program called RAY, which hires undergraduate students to work on research projects with faculty and other students. So RAY is a York-wide program, and LURA and NSERC are Lausanne only. And some faculty members also hire undergraduate students for research assistant positions, which is actually how I did my research position. There, there are also a wide variety of clubs, including clubs like the Lausanne Engineering Society or Women in STEM and Engineering. These communities help students connect with others who share similar interests. We also have a bunch of design teams which are a big part of the engineering experience because they help you apply classroom knowledge to real world projects, and they also look good in resumes, give you something to talk about in interviews. So some of our design teams include Lausanne Motorsports, we have a robotics team as well as Concrete Canoe. In addition, many of these teams also participate in regional and national competitions. So I know the robotics team, they participate in a competition, international competition in Alberta. And in addition to these, many clubs also host networking events and workshops. So this helps you build skills like resume writing and career prep, gives you career prep advice. And finally, we have other opportunities on campus. You can work, let me see. Students can participate in the work study program, which offers paid part-time jobs on campus. If you do really well in a course, you can become a class leader or a peer tutor, which provides academic support to students and helps them better understand the course material. Volunteering is also another option with opportunities in different faculties and organizations. And York in general has over 300 clubs, so you can easily find one that fits your interest, and there are plenty of ways to get involved in a way that interests you. So these opportunities are allow you to gain experience, build connections, and develop skills outside of the classroom, which are essential for both personal growth and career success. Excuse me. So at York, we ensure that students have access to all the support and resources they need in order to succeed in their programs and their careers. the main supports that we offer is Lausanne Academic Advising, which where we basically have academic advisors to help students plan their courses, understand program requirements, and make informed decisions to stay on track after graduation. If you need any help when it comes to academics, you can always speak to our academic advisors, and they're basically the university equivalent of your high school guidance counselors. So, academic advising is especially helpful when you're choosing specializations or managing a really difficult course load. In addition to academic support, there are also strong health and well-being resources available on campus. We have the Student Counseling Health and Well-being Department, which provides services such as mental health counseling, access to healthcare, and other wellness resources. These services are important because engineering programs can be demanding, and having access to support helps students maintain a healthy balance and perform their best. So, our program not only focuses on academics but also ensures that students are supported both personally and professionally throughout their journey. Okay, so this is our final section for today, some frequently asked questions. A question we often get is what is the difference between electrical engineering and computer or software engineering? So I think a simple way to think about it is to think about what you enjoy working on, and especially how much you like programming. If you think of starting with electrical engineering, this is a field, as I mentioned, this field focuses mostly on hardware and physical systems. You learn more about circuits, power systems, electromagnets, and electrical machines. So basically, how electricity is generated, transmitted, and then used in different real world applications. There is some programming, but that's not usually the main focus. Then we have software engineering, which is the most programming focused degree out of the three. You focus a lot on coding, working with algorithms, data structures, and building different applications, systems, and websites. There's very little hardware involved compared to electrical engineering. And next we have computer engineering, which is somewhere in between the two, because it combines both hardware and software. So you learn about circuits and electronics, but also things like embedded systems, microcontrollers, and low level programming. So computer engineering is a good choice are interested in how if you're interested in how hardware and software interact. For example, designing systems like smartphones or smart devices. Personally, I think one way to decide between the three is to think of how much you enjoy programming. As I mentioned, electrical generally has the least programming, and if you're like me and you don't really like programming, it might be the best option for you out of the three. Meanwhile, software has the most, and computer sits somewhere in between. There are other differences too, like whether you prefer working with physical systems or digital systems, theory versus application. So the choice comes down basically to your interests, whether you lean more towards hardware, software, or a mix of both. What made me choose, excuse me, what made me choose the song and this program? So one thing that made me choose the song is the strong focus on hands-on learning and collaboration. Many of your courses will include design projects and real world problems, so you're not just learning theory, but actually applying what you learn. We also offer co-op opportunities across all programs, which allows students to gain industry experience and build a professional network while still in school. Since I'm an international student, location and finances were also important factors for me. York is located in the GTA, which has a lot of opportunities for internships, networking, and careers when it comes to engineering and technology. So being in a major city makes things a lot more convenient, and it's also easier to connect with different companies and industry professionals. Compared to some other universities, I would say the tuition and overall costs were also an important consideration. So Lausanne to me felt like a good balance between quality education and affordability. So I think Lausanne stands out because it combines strong academics, hands-on learning, and access to opportunities in a major tech and engineering hub. How can I tell if this program is the right fit for you? So I will say that you really won't have a way of knowing if the program is right for you until you actually begin studying it yourself. One way to think about it is to ask, can I realistically see myself studying this for the next 3 to 4 years? If you feel strongly that you would not enjoy it or you wouldn't be able to get through it, then see some questions, I'll get back to them. Okay, so if you feel strongly that you would not enjoy it and you wouldn't be able to get through it, then it might be worth considering a different path that or degree that aligns better with your interests. So a good indicator is whether you genuinely enjoy the topics involved. For electrical engineering, that includes things like technology, electronics, and how systems work. If you're naturally curious about how different devices function, how electricity is used, and how systems are designed, then that's a really good sign. Another important factor is problem solving. As I mentioned, engineering involves a lot of work working with challenging problems, so enjoying math, physics, and figuring things out step by step, those skills definitely help. It's also worth thinking about whether you're interested in real world systems like power grids, communication networks, or electronic devices. So, electrical engineering is a very broad field. So, if you're not sure exactly what you want to do yet, you will still have the chance to explore different areas within electrical engineering. And at the end of the day, the biggest factor when it comes to deciding whether or not this program is right for you is your interest. So if you find the subject interesting and enjoy learning about it, the that's usually the strongest sign that the program is a good fit for you. And if you're unsure at the start, that's fine too. As I mentioned, we have a common first year, which is designed to help you figure that out. What has been a highlight of your time at Lausanne so far? So I would say one of the highlights of my time at Lausanne so far has been my first year. It was really exciting to start learning the fundamentals of engineering, and it was exciting to start university in general and being surrounded by so many students who were also passionate about technology and problem solving. I also really enjoyed the hands-on labs and projects because they helped connect what we were learning in lectures to uh, real life applications. And last summer, I also worked as a research assistant, which was my very first job. And that was definitely a highlight as well. Another great part of Lausanne has definitely been the community. It's a really supportive environment where students help each other out, whether that's studying together, working on projects, or just sharing advice about different courses. So this combination of challenging academics, this excitement, and as well as a strong student community has definitely made my time off at Lausanne a really memorable experience. Do I have any advice or tips for somebody starting the program? The first one is honestly to take first year seriously. A lot of people underestimate courses, they think they're easy, but and that is true because these courses are some of the most manageable courses you will have so far. And doing well in your first year will not only help you gain a better understanding and help you in your future courses, but doing really well in these courses can also boost your GPA. That matters later for things like co-ops, internships, scholarships, and also just reduces the GPA stress in upper years. Another big tip is to stay consistent with your work. In engineering, things can pile up really quickly. So if you fall behind, even by, I'd say, a week or two, that can make it really difficult to catch up on, especially when you have so many deadlines altogether. So even if you just review material regularly, that makes a huge difference because at least you're not cramming it the night before. And I would also recommend making use of all the resources available to you. Things like the past sessions I mentioned, peer tutoring, office hours, and all these support resources can be really helpful, especially when you're stuck academically. Talk to your professors, go to their office hours, attend academic advising if you need help. And these are some things that a lot of people don't really use at first, but they are there for a reason. Um, Another important thing is to find a good group of people to study with, just to ensure you're not struggling on your own because engineering can be challenging. So having people to work through problems not only helps you academically, but also makes the experience a lot more enjoyable. And finally, take your time, use this time to explore outside the classroom, whether that's clubs, design teams, or even just learning things on your own or building your own projects. We host a lot of employer and networking events throughout the year as well, because those are a great opportunity for you to meet professional engineers, help you gain internships and jobs, and give you more knowledge of the industry. Things like these help you figure out what you're interested in and gives you experience you can talk about later during co-op. So it's just really about staying consistent, studying hard, using your resources effectively, and putting in effort early because this makes everything much easier later on. Okay, I see a bunch of questions in the Q&A and chat. So, okay, what is the difference between a semester's course load versus oh, so- okay, what is better in terms of job availability between mechanical mechatronics, and electrical. What is the percentage of students who actually get co-ops versus those who don't? Does the university get companies coming on campus or is it all responsibility of students? Okay. So to answer your first question, what is better in terms of job availability between mechanical, mechatronics, and electrical? I'd say all three have equally strong opportunities, but they do differ slightly because these are different industries which have different demands and different roles. As I mentioned, electrical is one of the most versatile fields. Electrical engineers are needed in a wide range of industries like power, telecommunications, electronics, and even software related roles. So, because electricity and electronics are so involved in everything, I think this tends to give electrical engineers a broad job market and a very stable demand. Uh, I think mechanical engineering is also very broad, and they work in industries like manufacturing, automotive, aerospace, and there are a lot of jobs available, but it might be a little saturated. So between the three, the competition might be different. And mechatronics is more specialized. It combines mechanical, electrical, and some software. So it's more relevant in areas like robotics, automation, and smart systems, which are growing quickly. However, In my opinion, mechatronics is a little more niche. So the number of positions that are especially for mechatronics engineering might be low, but because it combines mechanical and electrical, mechatronics graduates can apply to both mechanical and electrical type roles. So I wouldn't say there's a single best option or one that has the most career options. In my opinion, electrical offers the most flexibility, while mechanical has the largest number of traditional roles. And not to mention, there are a lot of other roles that engineers can apply to that are not engineering related. So think project administration, consulting, things like that. The availability between the three also depends on your skills, your experience, and if you have any co-ops. So this is my take on this question. We also have mechanical and mechatronics engineering sessions similar to this one. So if you want to hear the perspective of someone who is actually studying mechanical or mechatronics, I suggest you also join one of their sessions. And what is the percentage of students who actually get co-ops versus those who do not? Does the university get companies coming on campus, or is it all responsibility of students? So, to my knowledge, I do not think we have any numbers on students who get co-ops versus those who don't. But I think we currently have around 500 students who are doing co-ops. I don't think we have any percentage of students. We don't publish that number. So does the universities get companies? Yes, we do actually. So once you are part of our co-op program, you will get access to the co-op job portal. That is basically a portal that contains a list of all the jobs that you can apply to. We also do get companies that come on campus. We have career fairs every September and with every September and January, where different companies come to campus. They have their recruiters and other industry professionals. You can go talk to them and learn more about the company as well as all the opportunities they offer. And other than these career fairs, there's also a lot of in-person and virtual networking events where you basically have a session that's being hosted by a company. You can talk to the recruiter, learn more about the company and what type of opportunities and positions they offer for both internships, co-ops, as well as full-time roles after you graduate. So, yes, it's not just your responsibility. Of course, you are free to apply to any position that you like, whether it's on the portal or outside of it. You can find your own job opportunities. But yes, we do have support from our co-op advisors, the university, and no, it's not just your responsibility. So I hope this answered both your questions. And I saw another one in the Q&A. So, semester course load versus an all-year course load. Mm, okay. Um, so I think the difference between a semester course load and a full year course load mostly comes down to how your courses are structured over time. So if you're talking about the semester system, which is what most of our courses have, your year is split into two main terms. You have fall and winter, and you take around 4 to 6 courses per semester. And each course is completed in these 4 months. So that means the pace is faster, but you also do have some time to rest between semesters and take new courses the next semester. But for an all year course load, you have a course that runs both semesters, so from September to April. And instead of finishing in a few months, there's more material and it's also spread out over a long period. So it can be a little slower and more in depth. Um, I hope that answers your question. And if you have any more questions, feel free to drop them in the chat or Q&A. Mhm. Oh, sorry. So that is the end of today's session. But at Lasan, we also want you to feel welcome, supported, and connected even before you officially join us. So there are several ways you can explore our programs and get extra support along the way. Firstly, we have weekly, excuse me. Firstly, we have weekly Lasan tours, which are led by upper year students and are tailored to your specific program interests. And these are usually in small groups. You can also join our Lasan community Discord. I believe you will find the QR code should be here. So through the Discord, you can drop your questions directly and chat with our student ambassadors to get a real sense of day-to-day life at Lason, or if you have any other urgent questions, someone will be able to help you out. We also encourage you to attend our Lason events as well as York open houses where you can meet our professors, staff, faculty, students, and get a tour of our buildings as well as the whole campus. To learn more about these opportunities, as well as others, you can scan the QR code that is at the top right of the corner or just search Discovery Days at Lassonde. Okay, and that is the end of today's session. Thank you so much for joining me today. I hope I was able to answer your questions. Um, here, I hope you keep in touch with us. Here is a link to Oh, sorry. Here's a link to the website that contains more information about our future events. And if you have any questions, feel free to email us at ask@lasonschool.com or you can drop your questions in the Lason community Discord.